Hi everyone. In today's video, we are going to discuss about the topic systems and classification of systems. For the better understanding of this particular topic, I have taken one example. As you can see here, the question number 1 states that we have to determine whether the given or the following system, that is y of t equals to 5x of t plus 2, are memoryless, causal, linear or time invariant. Okay, so what we have to determine, that the given y of t equals to 5x of t plus 2 is memoryless, causal, linear or time invariant. Okay, so first we will discuss about the definitions of all these memoryless, causal, linear or time invariant, and accordingly we will try to find out the systems classification. Okay, now let's see the solution. As you can see here, the given system is y of t equals to 5x of t plus 2. Now let us determine. The first part is, the first system classification is memoryless. Now, a system is identified as memoryless or static if the output at any instant of time depends on input sample at that instant of time only. Otherwise, it would be called dynamic or memory system if output depends on input sample as well as at some other instant of time. So what does it mean? एक सिस्टम को हम लोग मेमोरीलेस और स्टैटिक कब आइडेंटिफाई करेंगे? जब उसका आउटपुट किसी एक इंस्टेंट ऑफ टाइम पर सिर्फ उस वक्त के प्रेजेंट इनपुट सैंपल पे अगर डिपेंड करता है, दैट मीन्स दैट पर्टिकुलर सिस्टम इज ए मेमोरीलेस. एंड इफ इट डिपेंड्स ऑन present as well as past and the future one, so it needs memory, okay, to store the input or to store the output. So in that case it becomes what? A dynamic one. So to be memoryless system, it has to be dependent on the input sample at that instant of time only. Okay, now for example, let us see. The given system is y of t equals to 5x of t plus 2. So in this case, output y of t, you can see here, in this case output y of t is directly dependent on x of t. So what is x of t? X of t is the input value at the instant of time t. So y at time t is directly dependent on, I can say directly, or you can say it is only dependent on x of t input at that particular instant of time only. So by observing this equation, we can directly say that here y of t is a memoryless or a static system. अगर इस इक्वेशन में मान लो x of t के साथ साथ अगर x of t minus 1, x of t plus 2, लाइकवाइज अगर ऐसे कुछ टर्म्स होते यहाँ पर, तो हम कह सकते थे फिर कि ये जो सिस्टम है वो मेमोरी सिस्टम है, डायनामिक सिस्टम है. बिकॉज उस केस में क्या हो जाता है, एक्स ऑफ टी भी होता और उसके साथ साथ एक्स ऑफ टी माइनस 1 और एक्स ऑफ टी प्लस 2, या लाइक प्रेजेंट और प्रेजेंट, एडवांस्ड एंड डिलेड. सो अदर देन प्रेजेंट इनपुट, other instant of times dependent inputs are also available. So that becomes your dynamic system or a memory system. I hope this is clear now ki how to identify whether the given system is a memoryless or memory system. To be memoryless, it has to be dependent only on that instant of time input. Okay, that is your memoryless. Now the next is causal system. A system is causal if its output depends only on the present and the past input. See, mark this line here. A system is called as causal if its output depends on the present and the past, not future. Okay, past, and does not depend on its future value. Then that system is called as a causal system. For example, if I have to say what is the condition for causality, so y of t is a function of x of t where time is less than equal to tm. So it should be less than or equal to, it should not be greater than tm. Okay, so that system is called as causal. We will see this with the help of example. See, the given system y of t equals to 5 of x of t plus 2. Now this is a causal system because here the output y of t depends only on present input x of t. You can see here In this equation, y of t is dependent on only one input, that is your present input, not advanced one. So to be causal, it has to be dependent on present and the past. In this case here, at least present is there and future input is not there. So it's a purely a causal system. I hope this one is also clear. Now next is how to identify whether the given system is a linear system or non-linear system. Now before delving into the example part, let us understand theoretically what exactly linear system is defined. A system is linear if it satisfies the superposition theorem. Now superposition theorem is what exactly? So for that we will see the steps to check whether to check whether the given system is linear or non-linear. Okay, now let us check the linearity of a given system. Theoretically it is clear that a system is linear if it satisfies the superposition theorem. Now we will understand what exactly superposition meaning is through with these steps. Okay, now suppose first what you need to check, you have to check if the system is relaxed. What is the meaning of relaxed? We will see here. Relaxed means what? Suppose if apply x of t as a 0. Suppose you apply if you apply x of t means input value as a 0, then what you will obtain? Y of t equals to 5 into 0 at the place of x of t. Okay, so here we are getting 5 into 0 plus 2, so final value is 2. Y of t is 2 at x of t equals to 0. It means what? We are getting some value of output, though we have not applied any input. X of t equals to 0 means we are not applying any input, still we are getting some output. It means your system is not initially relaxed. Okay, relaxed means it is having some value. Okay, now the first step is to check whether the system is relaxed or not. Okay, now the next one is we have to apply individual inputs to the system and add the responses. कहने का मतलब है कि we have to apply individual inputs. For example, let us say two inputs are there, x1 of t and x2 of t. One by one we have to apply this x1 of t and x2 of t to the system. So what is the meaning of this sign here? Here it means that you are applying x01 of t to a system. This t identifies, or you can say this t symbolizes the system response, the system characteristic. Suppose if you are applying x of t to a system, you are getting y1 of t equals to 5x1 of t plus 2. Very simple. See, y of t is given now. Y of t is given 5x of t plus 2. So for x1 of t you have to simply put here x1 of t. So in that case it becomes y1 of t for x1 of t. Likewise it becomes y2 of t for x2 of t. Means you are applying two inputs, x1 of t, you are getting this response. You are applying another input x2 of t, you are getting this response. Okay, fine. Now the next what we have to do, we have to add these two responses. We have to add these two responses, means these two outputs. So we have added y1 of t plus y2 of t, and I have named it as y dash of t. After the addition we will get one resultant output, so that resultant output is named as y dash of t here. Okay, now y dash of t equals to y1 of t plus y2 of t. What is y1 of t? 5x1 of t plus 2. I have written here. Then plus, what is y2 of t here? 5x2 of t plus 2. That is again I have written here, and then we have to add these two. So by adding these two, what we are getting, this 5 common, x1 of t plus x2 of t, then this 2 plus 2 becomes 4. So here we are getting 4 here. Okay, now step number 2 is to apply the individual inputs to the system and add the response. We have obtained the response. Now the third step is apply sum of individual input to the system. Means what? In this step we have to first sum, we have to add first those inputs, x1 of t plus x2 of t, and then we have to apply to the system. Here we were applying individually, means x1 of t to the system, x2 of t to the system, but here in this case पहले हम दोनों को ऐड करेंगे, फिर ऐड करने के बाद फिर सिस्टम को अप्लाई करेंगे, एंड देन वी विल सी द रिस्पॉन्स. सी system is what system says that if you are applying input, if you are applying, suppose it is a system having a response t, and if you are applying here x of t, what you will obtain? You will obtain 5x of t plus 2. Simply, system's property is it will first multiply with 5 and then add 2. Okay, so this is a system properties for this particular case. So accordingly, what we are applying here, we are applying x1 of t plus x2 of t. So system will what system will do? System will first multiply the whole input with 5. So 5 is multiplied with the input, and then it will add 2 because it adds 2 here. So we get here what? Plus 2. Now let us compare the step number 2 response and step number 3 response. What you are getting here, what you are obtaining, what you are observing here, that this term is similar, but there is a difference here at the constant part, right? Here it is 4, it is 2. So to be linear, these two steps response has to be equal. इन दोनों को इक्वल होना चाहिए अगर हमें सिस्टम को लीनियर होना है. तो अगर हमें कहना है कि सिस्टम लीनियर है या नॉट लीनियर, सो टू फॉर अ सिस्टम टू बी लीनियर, दिस टू स्टेप्स आउटपुट हैज़ टू बी equal. So I have made here comment. Let us compare the RHS of the step 2 and step 3 to decide about the linearity. So after comparison, it is evident that it is observed that y dash of t is not equal to y double dash of t. So that's why system is non-linear. Okay, fine. So I hope this is also clear here. Now the next is time invariant. Time invariant or shift invariant. You can say time invariant or shift invariant. Now we have to determine whether the given system is time invariant or time variant. Time invariant or time variant. Now let us see. A system is time invariant. एक सिस्टम को हम time invariant कब कहेंगे? If time shift in input signals results in time shift in the output. अगर आपने इनपुट में टाइम शिफ्ट किया तो आउटपुट में भी टाइम का शिफ्ट होना चाहिए. अगर ऐसा होता है तो आपका सिस्टम टाइम इनवेरिएंट है, मतलब शिफ्ट इनवेरिएंट है. ऐसा नहीं होना चाहिए कि सिर्फ टाइम शिफ्ट कर रहे हैं इनपुट का बट आउटपुट पे कोई इसका अफेक्ट ही नहीं हो रहा है. अगर ऐसा हो रहा है तो उसको हम लोग टाइम वेरिएंट कहेंगे, मतलब उसको वो टाइम के साथ वैरी हो रहा है. सो फर्स्ट थिंग इज क्लियर हियर दैट कि हमें सबसे पहले एक चीज़ फिक्स रखना है. सपोज वी हैव टू रिमेंबर दैट व्हाट इज द डेफिनेशन ऑफ टाइम इनवेरिएंट. सो टू बी टाइम इनवेरिएंट, time shift in input signals results in time shift in the output. This will be more clear with the help of example. Let us see what are the steps to be followed to check whether the given system is time invariant or variant. Now, as we know that the given equation or given system is y of t equals to 5x of t plus 2. Now it is clear. Let us see. First, what we have to do? फर्स्ट वी हैव टू डिले द इनपुट. पहले स्टेप में क्या करेंगे, हम इनपुट को डिले करेंगे, फिर उस इनपुट को डिलेड इनपुट को सिस्टम को अप्लाई करेंगे. ठीक है. एज वी नो दैट सिस्टम प्रॉपर्टी इज व्हाट, इट विल टेक वट एवर इनपुट. अब जो भी इनपुट आप सिस्टम को दोगे उसमें वो 5 से मल्टीप्लाई करेगा और उसमें 2 को ऐड करेगा. ऐसा इक्वेशन में दिया हुआ है. एंड फ्रॉम दैट इट इज़ क्लियर दैट द सिस्टम विल परफॉर्म सच एक्शंस. ओके. नाउ पहले हमने क्या करना है, हमने इसको डिले करना है इनपुट को, फिर सिस्टम को प्रोवाइड करना है. सो दैट इज़ डन हियर. नाउ नेक्स्ट स्टेप में क्या करेंगे हम कि पहले हम सिस्टम को देंगे इनपुट को. वी विल अप्लाई इनपुट टू द सिस्टम. सो एज वी नो दैट in this particular example, it will take input and multiply with 5 and add 2. एंड देन उसको हम लोग डिले एलिमेंट से पास करेंगे, डिले करेंगे. सो डिले में क्या होगा, जहाँ जहाँ पे टाइम होगा उसमें डिले होगा. सो लेट्स सी इन दिस इनपुट, फॉर दिस पार्ट दिस इज एक्टिंग एज एन इनपुट. फॉर दिस पार्ट दिस वॉज योर इनपुट, वी ऑब्टेन द आउटपुट. नाउ दिस इज गिवन एज ए इनपुट टू द नेक्स्ट पार्ट. सो दिस इज योर इनपुट नाउ. So here x of t, so this t will be shifted Okay, so we are getting here 5 into x of t minus k plus 2. Now let us compare these two outputs. Compare the final result of both step 1 and step 2. Here it is found that final results, these two final results are same. That's why the given system is time invariant. Time invariant है system, ठीक है? Finally, now we can comment that the given system y of t equals to 5x of t plus 2 is memoryless. memoryless क्यों है? Because इसका जो आउटपुट है वो सिर्फ और सिर्फ प्रेजेंट इनपुट पे डिपेंड कर रहा है. सो देयर इज नो नीड हियर इन दिस पर्टिकुलर केस टू स्टोर द डेटा. सपोज, आई होप इट इज़ क्लियर नाउ ना, कि एक्स ऑफ टी की जगह से साथ साथ अगर एक्स ऑफ टी माइनस या फिर टी प्लस वाला टर्म होता तो उस केस में हमारा ये सिस्टम कैसा हो जाता? डायनेमिक हो जाता, राइट? सो दिस इज योर मेमोरीलेस और स्टैटिक सिस्टम. Now second is causal. It is also we have seen here how a system is called as, how and when a system is said to be causal. A system is said to be causal if it depends on present and the past. So in this case, at least this output is depending on present. There is no any term here which shows the future value. That is advanced one. That is no, at least like x of t plus wala term. Okay, that's why this is your causal one. Now the non-linear हमने चेक किया अभी कैसे आइडेंटिफाई करते हैं, स्टेप्स को फॉलो करना है. देन टाइम इन्वेरिएंट का भी हमने स्टेप्स देखा, उसको भी फॉलो करके हम लोगों ने ये आइडेंटिफाई किया. आई होप it is clear now that how to identify a given system to be memoryless or memory, causal, not causal, non-linear, linear, time invariant and time variant. Okay, thank you for this. We will continue with another topic by the next video. Thank you everyone.